Why did Voyager 1 journey through space? No spacecraft has gone farther than NASA's Voyager 1 to fly by Jupiter and Saturn. Voyager 1 crossed into interstellar space in August 2012 and continues to collect data. Voyager 1 was the first spacecraft to cross the heliosphere, the boundary where the influences outside our solar system are stronger than those from our Sun. But before we begin, please like and subscribe to our YouTube channel for such amazing and informative videos. Voyager 1 was launched into space on September 5, 1977, by NASA with the primary objective of exploring the outer solar system and beyond. The mission was part of a broader effort to learn more about our solar system and the universe as a whole. Voyager 1's journey was made possible by a rare alignment of the outer planets that allowed for a gravity-assist trajectory. This enabled the spacecraft to visit and study Jupiter, Saturn, Uranus, and Neptune, sending back valuable data and images. The mission had several specific scientific objectives, including the study of the atmospheres, magnetic fields, and rings of the outer planets. Voyager 1 was also equipped with instruments to detect and study cosmic rays, charged particles, and plasma waves. In addition to its scientific objectives, Voyager 1 was also tasked with providing a family portrait of our solar system. The spacecraft captured images of the planets, including Earth, from a perspective never before seen, providing an unparalleled view of our place in the universe. Voyager 1's journey was also motivated by the desire to explore and learn more about the outer reaches of our solar system, including the Kuiper Belt and the heliosheath, the boundary between the solar system and interstellar space. Overall, Voyager 1's mission was a groundbreaking achievement in space exploration, providing important insights into the planets of our solar system and the vastness of space beyond. It began its Jovian imaging mission in April 1978, when it was about 165 million miles, 265 million kilometers, from the planet. Images sent back by January 1979 indicated that Jupiter's atmosphere was more turbulent than during the Pioneer flybys in 1973 and 1974. Beginning January 30, 1979, Voyager 1 took a picture every 96 seconds for a span of 100 hours to generate a color time-lapse movie to depict 10 rotations of Jupiter. On February 10, 1979, the spacecraft crossed into the Jovian moon system, and in early March, it discovered a thin ring circling Jupiter, less than 19 miles or 30 kilometers thick. Voyager 1's closest encounter with Jupiter was at 12:05 UT on March 5, 1979, at a range of about 174,000 miles, 280,000 kilometers. Following which it encountered several of Jupiter's moons, including Amalthea, at a 261,100 mile, 420,200 kilometer, range, Io, 13,050 miles or 21,000 kilometers. Europa, 45,830 miles or 733,760 kilometers, and Callisto, 78,540 miles or 126,400 kilometers. Among the most interesting findings was on Io, where images showed a bizarre yellow, orange, and brown world with at least 8 active volcanoes spewing material into space, making it one of the most, if not the most, geologically active planetary bodies in the solar system. The presence of active volcanoes suggested that the sulfur and oxygen in Jovian space may be a result of the volcanic plumes from Io, which are rich in sulfur dioxide. The spacecraft also discovered 2 new moons, Thebe and Nadi. Following the Jupiter encounter, Voyager 1 completed an initial course correction on April 9, 1979, in preparation for its meeting with Saturn. A second correction on October 10, 1979, ensured that the spacecraft would not hit Saturn's moon Titan. Its flyby of the Saturn system in November 1979 was as spectacular as its previous encounter. Voyager 1 found 5 new moons, a ring system consisting of thousands of bands, wedge-shaped transient clouds of tiny particles in the B ring that scientists called spokes, a new ring, the G ring, and shepherding satellites on either side of the F ring satellites that keep the rings well defined. During its flyby, the spacecraft photographed Saturn's moons Titan, Mimas, Enceladus, Tethys, Dione, and Rhea. Based on incoming data, all the moons appeared to be composed largely of water ice. Perhaps the most interesting target was Titan, which Voyager 1 passed at 5:41 UT on November 12, 1979, at a range of about 2,500 miles, 4,000 kilometers. Images showed a thick atmosphere that completely hid the surface. The spacecraft found that the Moon's atmosphere was composed of 90% nitrogen. Pressure and temperature at the surface were 1.6 atmospheres and -292 degrees Fahrenheit, -180 degrees Celsius, respectively. Atmospheric data suggested that Titan might be the first body in the solar system, apart from Earth, where liquid might exist on the surface. In addition, the presence of nitrogen, methane, and more complex hydrocarbons indicated that prebiotic chemical reactions might be possible on Titan. Voyager 1's closest approach to Saturn was at 2346 UT on November 12, 1980, at a range of about 78,290 miles, 126,000 kilometers. Following the encounter with Saturn, Voyager 1 headed on a trajectory to escape the solar system at a speed of about 3.5 astronomical units, 325 million miles or 523 million kilometers, per year. 35 degrees out of the ecliptic plane to the north, and in the general direction of the Sun's motion relative to nearby stars. Because of the specific requirements for the Titan flyby, the spacecraft was not directed to Uranus and Neptune. On February 14, 1990, Voyager 1's cameras were pointed backward and captured about 60 images of the Sun and planets, the first portrait of our solar system as seen from the outside. The images were taken when the spacecraft was about 40 astronomical units from the Sun, 3.7 billion miles or 6 billion kilometers. A mosaic of those images became the pale blue dot image made famous by Cornell University professor and Voyager science team member Carl Sagan, 1934 to 1996. The image has also been called the Solar System Family Portrait, even though Mercury and Mars can't be seen. Mercury was too close to the Sun to be seen, and Mars was on the same side of the Sun as Voyager 1, so only its dark side faced the cameras. These images were the last of 67,000 images taken by the two Voyager spacecraft. Their cameras were turned off to save power and memory for the interstellar mission. All the planetary encounters finally ended in 1989, and the missions of Voyager 1 and 2 were declared part of the Voyager Interstellar Mission, VIM, which officially began January 1, 1990. The goal of the new mission is to extend NASA's exploration of the solar system beyond the neighborhood of the outer planets to the outer limits of the Sun's sphere of influence and possibly beyond. Specific goals include collecting data on the transition between the heliosphere, the region of space dominated by the Sun's magnetic field and solar field, and the interstellar medium. On February 17, 1998, Voyager 1 became the most distant human-made object in existence when, at a distance of 69.4 astronomical units from the Sun, it overtook Pioneer 10. On December 16, 2004, Voyager scientists announced that Voyager 1 had reported high values for the intensity of the magnetic field at a distance of 94 astronomical units, indicating that it had reached the termination shock and had now entered the Helios heath. The spacecraft finally exited the heliosphere and began measuring the interstellar environment on August 25, 2012, the first spacecraft to do so. Jupiter accomplishments. During the Jupiter leg of its journey, Voyager 1 explored the giant planet, its magnetosphere, and its moons in greater detail than the Pioneer spacecraft that preceded it. Voyager 1 also used Jupiter as a springboard to Saturn, using the gravity assist technique. Saturn accomplishments. Voyager 1 was the second spacecraft to visit Saturn. It explored the planet and its rings, moons, and magnetic field in greater detail than was possible for its predecessor, Pioneer 11. Did you learn something new about Voyager 1, a journey through space that you didn't know before? We hope you did. So, if you're interested in learning more amazing facts about space journeys, make sure to subscribe to our YouTube channel and hit the bell icon to get notified of our new videos. Please like and share the video. Don't forget to comment your views on this. Thanks for watching to the end.